in front of Khufu's pyramid at level ground facing one of the four faces, which are the triangles. In other words, you're standing about 300 feet away in the middle of one of those faces looking straight on. I'd like you to draw what you would see. It should take you about 10 seconds. Do not say this out loud. What would you see? Don't say it. Just draw. Okay, take a look up here. If you're standing straight and you're about 300 feet away, the only thing you're seeing basically is a flat triangle. Understand? Okay, now we're going to try another perspective. This is called orthogonal drawing, which means to draw a flat image of a 3D shape from a certain perspective. Now, when you go, those of you who ever take an engineering class, doing orthogonal drawings are really important. You take a 3D shape. There's actually 6 different perspectives you have to draw. Front, back, left, right, top, bottom. We only just did the front version. Now we're going to do the top. So number 2 says, imagine you're a hot air balloon, but let me give you a visual for this. Imagine you are that hovercraft camera, and you're directly looking, or that image, directly over the apex here of the pyramid, looking downward. Draw what would be seen. You're that hovercraft there, looking directly down at the apex. Draw what you would see. You're looking directly down at the pyramid. Draw what you would see. These pyramids have 4 sides. All right, guys, got it? It should be pretty quick. Look. Yes? Looking directly down? All right. Now, we're going to switch gears. This is called orthogonal drawing. Orthogonal drawing. It means 2D drawings from various perspectives. Now, this third one is not orthogonal drawing. I'll explain why in just a moment. Number 3 says, imagine you're standing 300 feet away from a pyramid facing a corner. A corner. Those of you who are in art, this is called the perspective view. The perspective view. I'd like you to draw what you would see. This is going to be a bit trickier. You're standing at the corner. That would be great, Andrew. If you have an opportunity to take an art class at Valley, you should. We've got some amazing teachers in the art department. Yeah, art's not necessarily an easy class, but you develop some amazing skills. And you're going to get some of the highest quality teachers of art in the entire Bay Area. So, and that's just, I'm not biased. I know my coworkers. Alrighty, guys. If you've done this correctly, this would be considered the 3D view. Yeah? So you're looking, when you're at the corner, you're able to see 2 different directions. Yes, sir? Okay, today, obviously, I'm not making it a do or die issue, but warning, guys, yes, you need to develop the capacity to visualize in 3D, which means drawing in 3D, which means in order to show this in depth, yes, Max, to answer your question, by the next class period, I expect to see those dotted lines. Okay? Yes?
All right, never mind.
No. Okay, last one. This is called the net view. Now, go like this with your hands. Pretend you have a physical pyramid in your hand. Okay, now I'd like you to unfold the shapes. Unfold it. Now lay them flat. Now start drawing. What would that look like? Unfold the shapes, start drawing. What would that look like? Unfold the shapes, start drawing. What would that look like? This is called the net view. The net view. Unfold it. Did you draw it unfolded? Okay, look. Yes? Okay. This is called the net view. Turn the page. The net diagram. Okay, Andres, lights please. It is a square-based pyramid versus a triangular-based pyramid versus a hexagonal-based pyramid. Nope, because that right there is a triangle, isn't it? And it's a pyramid. So, yes. Guys, prisms and pyramids, you can't just say prism and pyramid. Is it a triangular prism? Is it a hexagonal prism? A pentagonal prism? A dodecagon prism? Is it a triangle-based pyramid? A square-based pyramid? Okay, so fix the ones. So the ones people were missing was the fact that this is a square-based versus triangular prism and pyramid. Okay. All right, each of you put your hands in the bucket, please, and pull out either a blue or yellow. Hold this. So let's just kind of like put your hand physically on it. It's like a brick of cheese, right? Slice of cheese. Okay, when we unfold this, how many triangles do we have?
2.
2. And then how many rectangles do we have? 3. So now the easiest way is to color code everything. So let's start with that 17, because that one is already color coded for you. And I told you when you unfold it, that one goes there.
Oh, yeah.
Okay? Now, question. What else is 17? The other side over here. You're right?
Oh, I see.
Okay. Now, so that, I just did this. Now, take a look here. Watch very carefully. Do you see that this is a rectangle?
Yeah.
What?
Mind blown.
Do you see that that's a rectangle?
Whoa.
Okay. All right. Now, warning. The rectangle that's there is right here. Sorry, I've got mine. Do you see when we fold it? When you fold it, this rectangle, this edge meets here.
Oh, and the other one.
Yeah. So where else is 17 besides those 2 red spots? Where else?
This long. Yeah.
It's right there. Do you see it? Because they join at the seam there. That's a little tricky. You have to imagine that the 17 here folding and meeting the rectangle, and it's a seam. When you fold it, they connect. Okay? So these are 17.
Having a little problem there.
Okay? Now, let's see where the 15 goes. 15's back here. So it's connected to the 17. So let me see you guys. I want to see where you put your 15s real quick.
Isn't it?
15?
Isn't it here?
Nope. 15's not there. Where's the 15?
Right here.
There you go. Where are you going to put the 15?
Right here.
Okay, no. 15's joined at, look, 15 joins the 17.
Here.
There it is. Okay, so it's joined. That's 15. Then that means that's 15. You okay with that?
Yep.
Okay,
Oh,
and
this is a
so,
lot more confusing than I thought.
well, no, it's all about visualizing. You guys aren't used to using your visual side of your brain in a math class. You're used to just pushing numbers around. Gone are those days. Okay? Now, do you see that this is that back one there? Between the 15? Do you see that rectangle?
Oh, yeah.
You see that? Okay, ask yourself, what's the height of the rectangle, or the width, if you will? 9. You're right. So this is 9. Pull that 9 down. Where do you think that 9 belongs? 9
Right here.
is it's the width of that. Yeah, it's the width here, plus it's the width there, plus it's the width
Oh,
there.
because they're all like.
Because they wrap around. So these are all 9.
What about the 8 then?
Yeah, what about the 8? Let's figure that out.
Oh, it's a smaller one.
Okay, so the 8 completes our triangle. Do you see it?
Oh, I missed.
So that's 8. That's 8. Right? Because that completes our triangle. Let me switch colors for the triangle here. The light pink triangles. Okay. Question. What's this edge here?
That,
Okay, imagine, fold it back.
8.
Is it?
You don't look convinced.
I don't know.
8.
How did you open
Okay,
it?
watch.
You fold it.
You fold
That's
it.
so confusing.
You have to physically do it. Like, it literally helps to imagine the paper in your hands and you folding, like, there goes the triangles, and you
Like the
swing it
box
around.
paper.
Exactly. Yes, there's a reason for all my maniac stuff. There is a reason. There you go. That is done, my friends.
Oh.
Okay?
Looks like a spaceship.
Now, do you want to do one more?
Yeah.
Okay, we're going to go the other way.
Mine
Okay.
looks like Christmas.
Now, we're going to do this one right here.
We need purple.
So now we have a net. Okay, now we're doing the right-hand side. Okay, hold your hands flat. Okay, so you have a triangle with 3 flaps. You ready? Okay, fold those flaps up. 1, 2, 3. Now ask yourself, as you fold it up, which one of these solids does it match?
Triangular prism.
Bingo. Bingo. That's why we did this, so you can recognize it. So this is a triangular prism. So we're going to start with the base. Pyramid.
Yeah.
Did you say prism or pyramid? I said prism.
You said prism.
That was wrong. Okay. So we're going to draw this in 3D. So watch. 3D means I have to dot this back because we can't technically see it. This is 11 and 11. Right? You okay? What's that back edge? Bingo. Now, to make a pyramid, you just put a dot at the top. And now we're just going to pull it up. And a triangular, we can see all 3.
11.
Okay, well, it's 11 on the left, 11 on the right, and 6 in the back. Now, question. I want to see you guys. Where does that 10.2 go? When you fold it up, where is it? Now, I want you to draw it before I show it to you.
Isn't it like here? Or like there?
No, it's on the face, dear.
Oh,
See, the 10.2 is on one of the flaps.
Yeah, it's a pop.
Nope, it's not on the base. We fold that flap up. See, it's a flap. And we fold it up.
So it's
Can you visualize it? Where did that 10.2 go?
like it's here. No.
Okay, watch. Do you see that that's the top?
Yeah.
Okay, now, is it going down an edge,
Oh,
or is it
that's
going
the top.
to the midpoint? It's going to a midpoint, so we're going from top. Well, all of these meet at the top, right? That's the whole point. They fold to an apex.
Oh, so it's here.
So it goes from the top to a midpoint. So that 10.2 goes down the face.
Oh, that's awkward.
It's awkward, but it's what you need.
Taco.
Okay.
Tacos sound really good. Or enchiladas. Oh, I'll go to my grandma's.
Ooh, she makes good Mexican food?
Yeah.
Okay, so we're on page 7. I'd like you to unfold it and draw the net. Do this now. You've done this several times already. Unfold it, draw the net. Pull over whatever numbers you can. Unfold it and draw the net, please. Unfold, draw net. Pull over whatever numbers you can. Those of you that are on a different page, please get on the correct page, guys. It's really important. Pull over whatever numbers are possible. Okay, look up here, guys. Ready? Put your hands like this. Imagine you have a pyramid. Watch very carefully. This 24 is what's called the altitude. It's down from the very apex, right there, to the smack dab middle of the base, which means it smacks there. When we unfold it, that's where the apex meets. Frozen. Yes. Give it a second. Ready, guys? Question. When you unfold this, what happens to the 24?
It's still standing. No
It's still straight. Now, is it possible to get that 24 on the flat surface?
No.
No, guys, that's where the trick is. Because the 24 is a 3-dimensional height, not a 2-dimensional height. Problem is, if I want the area of these triangles, don't I need this? Don't I need that? Right? Okay. See all the greens? I want you work backwards. Where is this green segment in the original? Draw it. Let me see if you can't draw that correctly. Where is that green segment in the original? Let me see if you can't draw that. Okay, ready? Watch. Green segment goes from the apex to the middle of a side. That, my friends, is your X. How many of you drew that in the right place? Or you maybe you drew it down this side. Some of you maybe drew it down that way. Okay? Either way, I'd like you to do this, please. Trace down the 24. Everybody, trace down the 24. Trace from that green dot straight to that. And go back up to X. Now pull, if you can't recognize that, that's a triangle. Pull that out. This is 24. This is X. Raise your hand if you know. Don't say it out loud. Raise your hand if you know what that orange is. Raise your hand. Raise your hand and look at it very carefully. You know. Don't say it. Don't say it. You know what the orange is. Ready? Okay, those of you who don't have your hands raised, look at them bewildered and say, how do you know what the orange is? Ask those.
How do you know what the orange is?
What is it? Start explaining. Start explaining. Yes. Okay, ready? Solve for X. Go. Solve for X. 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 Solve for X.
Solve for X.
Solve for X, guys. Solve for X. 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 Pythagorean Theorem. You do need Pythagorean Theorem here. Solve for X. Yes, sir.
I found X way ahead before you started.
Because you knew the triplet?
I recognize how, I recognize what it is.
Excellent. I'm glad to hear it. I'll ask you in a moment for it. Yes, sir. Pythagorean. Okay, watch. 24 is on the inside height of the pyramid, right inside the gut. When I unfold that, the 24 there, get our visualize. That 24 is not the gut. I mean, the 24 is the gut. See here? We need this. 24 is inside. See that? So that friend is not 24. Okay, Caleb, what's that? Okay, ready? Let me wrap this up with you guys. That's 25. Ready? Now we're going to do surface area like so. This will go faster now. Track with me. It'll go real fast. Step number 1, we have 1 square. That's easy. Okay, that is area equals side squared. So that's simply 14 squared. Get me that number. Did I give you units earlier? No. Not really. Okay, so it's going to be units squared. Ready? Jessica, what is that, ma'am? 14 times 14? There you go. Do the math next time. Ready? That's 196. Okay. Now, let's pull over one of these triangles. We only need 1. So there's your triangle, but we have 4 of them. Follow with me, guys. Ready? Equals. That's area equals base times height over 2. In this case, our base is 14. Right? Our height of the triangle we just found out is 25 over 2, but we have 4 of them. Okay? Get me that number. And if you're really on top of it, you're going to do it without a calculator. Yeah, you can do it. You can do it. It's really honest. All right, guys, take a look. How many got 700? So the final, how do you get the total surface area here? All you do to get the surface area is just add everything up. So the total surface area, that's the area as if this was a present wrapped in wrapping paper, is 896 units squared. If you're ready to about have a hissy fit right now and you want to do one of more with me, come on down. We'll do it together. The rest of you keep working. I'm going to do page 9, problem 4. Page 9, problem 4. You're like, Miss Way, I'm not ready to be alone. Lights, please, Andre. Bring your calculators, guys. Students, you're working on pages 8 and 9. 8 and 9. 8 and 9. I only got one taker? Oh, well. Here, get some colors. Okay, make sure I'm still recording. Yes. All righty, Nevin, you ready? Okay. Now, I want you to hold this, pretend, we'll go like this in your hand. I want you to feel it. You feel it's like a wedge, it's like a doorstop, right? Okay, so we have a bottom, touch the bottom, you got a bottom, we got a side, right? And then we have a diagonal part, like a wedge, and then we have two what? Triangles. Okay, so we're going to unfold this very carefully. Okay, and I'm going to color code it, so I've given you colors if you'd like. So I'm going to start with what I consider the base, which is going to be the 24. And then what's that length right there?
15.
Do you see it's 15? Okay, so we're going to start with that. So that's the 24, and then we have 15. And that's going to be right here, 24, whoops, get out of the fat pen, and 15. That's going to be this bottom one in green. You okay? Okay, now we're going to go for the back. So this is still 15, right? And now we're going to go this, and what's our width?
7.
That's 7. So we keep the 15. The 15's here, and we're going to go this way, 7. So I'm going to make it a little smaller so it's kind of like to scale. So this is now 7. Did I lose you? You okay? This is 7. You still chill? Got it? Okay. Now, do you see, let's get that triangle. Do you see the triangle? Okay. And there's a right angle there. Okay, the flat part of the triangle hinges along what edge?
7.
Okay, and the 24. So the legs of the triangle have to match up to the 7 and the 24. So go like that. That is 24. You okay with that? That's this guy right there. And do you see that this edge matches with this edge? So you're going to go 7 that way. There's your triangle. Do you see it? There's your wings. Okay, so I'm going to bring it down. And there's 2 of them. So we got right angles, right angles. This is 7. That's 7. You still tracking with me? Okay. How many rectangles are there? How many total rectangles do you have there? Okay, watch, guys. We have the green bottom, right? Pretend like that. We've got the green bottom. We've got the blue back, right? What rectangle are we forgetting right now? Do you see there's a rectangle there? It's a little hard to see it. Oh, there it is. Yes, I'll do sign-offs momentarily. Yes.
Are we supposed to find this?
Yes, you are.
Say on it that we have.
It's right here. Yes, of course you do. Pull apart. You're going to find the net. Yes, you're finding the surface area. Of course.
Okay.
Yes. Okay, so do you see we have another one going, I'm going to do this way, pink right there, right? Okay, this is still 15 and that's still 15. What is the only edge you don't have? Do you see that? Uh-huh. And do you see that that matches to this? Okay. So you're going to use Pythagorean Theorem to find what I'm going to call that x, and the x also goes there. So from here, 7 squared plus 24 squared equals unknown squared. Once you have everything, you just hammer out all the areas. Okay? You know how to do areas of all this, right? Okay.
Thank you.
Once you draw it, it's downhill. It's the drawing that's tough, and I recognize that.